Today we are looking at limits that fail to exist. So let's say we were given the function the absolute value of x over x, and we wanted to take a look at the limit as x approaches 0 of this function. Well, we know that the function is undefined when x equals 0. But remember, when we talk about limits, we don't really care what happens at x equals 0. We're talking about what happens as x gets really, really close to 0. So we're going to take a look at the graph. And if you don't know what this graph looks like, that's okay. We're going to make a table of values. So we're looking around 0. And if you substitute, here we get the absolute value of 2 over 2, which is 1. 1 over 1 will also be 1. And you can kind of see how no matter what value you choose greater than 0, this is always going to turn out to be 1. So on our graph, for all values that are greater than 0, we are going to have function values of 1. So we're going to have open circle here, function values of 1. Now, when our x values are negative, when we take the absolute value, that comes out to be positive anyway. Here we have 1 over negative 1, 2 over negative 2, and you'll see that any value less than 0 will give us a function value of negative 1. So here we go, negative 1, and there's our graph. Okay, so this is f of x. So here, if we're looking at what happens as x approaches 0, you'll notice that from the left, our function is always at its limit. So the limit from the left is equal to negative 1. So here, from this side, f of x is approaching negative 1. But from the right side, as x gets closer and closer to 0, our function value is always at positive 1. So the limit as x approaches 0 from the right is positive 1. Now these two don't agree. From one side we get negative 1, from the other side we get 1, and if you remember from our informal definition, the limits from the left and the right have to agree. So in this case, we would say that the limit as x approaches 0 of our function does not exist. In order for a limit to exist, the limit from the left must be equal to the limit from the right. All right, let's consider this function now. F of x equals 1 over x squared. And let's talk about the limit as x approaches 0 of this function. Now this graph is always positive, always above the x-axis, because we've got 1 over x squared. We've got a horizontal asymptote around along the x-axis and a vertical asymptote along the y-axis. So our function has to look something like this. Now notice as x gets close to 0, that f of x is not getting close to a number. F of x just keeps getting larger and larger. Same thing from the other direction. As x is getting closer and closer to 0, f of x continues to get larger and larger. So in this case, there is also no limit. The limit as x goes to 0 of f of x does not exist. And the reason is because our function values are going towards infinity. Okay, here's our last case. This is the graph of sine of 1 over x. And what's really cool about this is that you've got all of these oscillations happening here. So lots of oscillations. So our function is always bouncing between 1 and negative 1, 1 and negative 1. And what we can't really see here is that there are infinitely many oscillations. So as x gets closer and closer to 0, our function values just keep bouncing back and forth between 1 and negative 1. So our function isn't getting closer to any real number as x approaches 0. So for this function as well, as x approaches 0, this limit does not exist. So here is our summary. We've got 3 cases at which the limit fails to exist. The first case is if the limit from the left is not equal to the limit from the right. 2, if f of x is increasing or decreasing without bound. That means that f of x is approaching infinity or negative infinity. And 3, that's if f of x oscillates between 2 fixed values as x approaches c.